Hello everyone, I hope you're all safe and fine. So let's wait a couple of minutes here just until more people join, and then we'll go right into it. Maybe until then I'll just talk briefly about what we did so far. So yeah, this is the third session in this series about the 12 factor apps. And so far we've discussed three factors from the 12 factors: code base and dev prod parity and dependency management. And today I'll be discussing two more factors, first of which is config. So how can you manage the configuration of your app if you need to have configuration for your app, how to do that in a safe manner, how to deal with configs or configurations when you're using a code base and sharing code with others. So this is one thing I'll be discussing today. And let's wait just a couple of seconds and then jump right into it. Till then, if anyone has any questions from before, just feel free to shoot them so that we can start fresh here. And also, if you're here, just let me know in the chat. Okay, so let's dive into it. So as I mentioned, today I'll be talking about factor number 3 of the 12 factors, which is config, and its motto is store config in the environment. And as usual, I'll start by defining some vocabulary that we should be aware of whenever we're dealing with this factor. The third vocabulary here is configuration. So what is a configuration? And basically an app configuration is everything that is likely, as mentioned here, to vary between deploys. And what I mean by that is that it's a setting for your app. So if, for example, this setting is something like a value that you need for your app to run, and then this value changes depending on the environment you're running. So for example, if you're doing it locally, you need like a certain value. If you're doing it in staging, you need another value. If you're doing it in production, you need the third value. This is what we call an app config. And this usually includes like resource handles. And what I mean by that is, for example, like connection strings for different services like databases and banking services, credentials for something like Amazon S3 to store your files on, or for some API like Twitter's API or Facebook's API. So like some other values such as like host names or configurations for your app to identify it whenever it's going into production. So all of these are known as configurations. And an example of that is as follows here. So imagine with me that we have a database server, in this case here a Postgres server, which is responsible for persisting the data of our application, and we need to connect to it. So as most of you might know, in order to be able to connect to a server, there are a couple of parameters that we need to have, one of which is the host, where this service lives, the port on which it's listening, and maybe some other parameters, like in this example here, to have like a username and a password, database name. So usually what might be seen in the apps is these kind of configuration values being hard-coded in the code. And what I mean by hard-code is that they are explicitly written down in the code, as we can see here. So this is like a main function. And as I mentioned, I'll be using the Go language to demonstrate the factors throughout the sessions. So this is the main function in Go. And in this statement here, I'm using some package called SQL that opens a connection to a Postgres server. And the username, which is root, the password, which is secret, are both included in the code without being encrypted in any way. So this is what I mean by hard coding the configuration in the code. And this is totally against the like what that 12-factor methodology advises with. So it's a violation of the 12-factor, which requires like strict separation of config from code. So the 12-factor app, this config here, this config factor, is mainly about separating our code base, like the code where our app's logic happens, from any configuration that this code needs. So that doesn't mean that I'll be running the code without the configuration, but I'll be running it and injecting to it or passing to it the configuration in some other way that we will learn about in a couple of seconds, instead of having to do it, as I mentioned here, like in a hard-coded way, where the values are hard-coded into the code. Like one problem with this is actually that if these values are sensitive information, and then you share this code like publicly somewhere, everyone will have access to your database instance. That's one problem, and mainly the major security hole that we find in hard coding configuration values like this. Another problem is that if this code needs to be run on different environments, given for example that you have a database for the staging environment, another instance for the production environment, and each of these databases keeps its own version of the data, then you will need different configuration for each of these instances. So for example, if one lives in a website called example.com, another one in a website called example4 or 2.com, you need to change this configuration whenever you're deploying your app in order to accommodate for the environment you're deploying the app on. And this will require you to make changes to the code before you deploy to the environment, depending on which environment you are targeting. And as we mentioned in the first factor, code base, this defies the rule for having source control that is the same for each environment. And what I mean by that is that we need to make sure that the source code of our app does not change between environments, as we mentioned before in the first session. And if we have configuration like that, we won't be meeting this factor. So there should be some way in order to avoid that. And basically, for you to be definite about whether a certain value is a configuration or not, there's something similar to the litmus test that we used to have like back in the days when we were learning about chemistry that differentiate between acidic and alkaline solutions, which is the following question. You should ask yourself, can I make my app, my code base, open source right away or not? In case there are sensitive information in it, most probably the answer to this question will be no. No, you cannot make it open source because of the credentials that you will be exposing to the world. And in this case, this kind of value should be considered as a config that should be abstracted away from the code base of your app and put in and provided to the app in some other way that we'll discuss in a second. So one example of handling configuration is to use what we call configuration files. So in this example, we have like a file called config.yml, and the YML is just like an extension for a file the format that basically lays out the values as we can see on the left here, where we see the key on the left and its value on the right. So it's basically a set of keys and values. So in this example, we can see that we have like this DB config, which is short for database. It has like a driver, a host, a port, username, password, and a database name. And we can see these are the same values that were included before in the example we saw over here, the hard-coded example, except that these values, instead of being inside of the code, we extracted them into a file, and in this case it's called config.yml. And because this file includes sensitive information that should not be shared with the public, these files should not be checked into revision control, which means that it should not be part of your repo that is being pushed to like GitHub, for example. But it's always one of the best practices is to include a file with a similar name, except that it has, like, for example, -example at the end, and this file would hold the same contents of the config.yml file, except for the values. So it will have the same structure with the keys, but for the values you can supply some example values so that anyone who clones your repo will be able to generate his own or her own config.yml file from this example file, and then modify the values inside of it to meet their setup or environment. So now you make it easier for new developers joining your team to be able to run the app and recreate the configuration files that are needed by the app. This solves the problem of not hard coding the values directly inside of the code, but it has its own problems as well, in that it is a file, which is which could be confused with other files inside of your app, which might lead it to be mistakenly checked into source control, which is a problem that we are trying to run away from. So even though config files extract the sensitive information from the code, it's not always advised to use them because of the problem that there might be a lot. You might have a lot of configuration files lying around your application, and in case you missed one of them, it will be included into your commit in the source control and then exposed to the public if your project is open source, for example, and that's a huge problem. So as you can guess, there is another way to handle it, but first let us do a quick demo using configuration files. So I'm creating a new app over here, and on the left you can see this is the GitHub repo where I keep all of the code of all of the sessions. I'm leaving it here just for reference, but yeah. Let us start a new app. So basically I'll be building an app that when it runs, it connects to a Postgres instance. It reads off some data from it and prints them in the terminal. Okay, just as an example of how we can connect to services, and then we will see how we can use configuration files to solve our problem. So first I'll be hard coding everything inside of the code, and after that I'll be extracting these values into config files and showing you exactly how to do it. For those of you who don't have Postgres installed, as I mentioned last session, we can make use of Docker to run it on our machines without having to install anything. So let me first write out the program, and then we'll worry about Postgres in a minute. So in order to start a new programming Go, we should have this main function. And to be able to connect here, let me quickly search for like Golang Postgres example. I don't know, let me just pick anyone and see how it works. I just need some reference to copy code from, nothing more. So yeah, we can see here that it starts by defining this variable, which basically holds the different configuration options for our code. And in this case, it needs like a host, a port, a user, a password, and a database name. So let me define these variables beforehand. Currently, our host is going to be localhost. The port is going to be the default port for Postgres, which is 5432. The user is root, password is secret, and database name is app. Okay, these values I haven't defined yet, but when I start the new Postgres instance, I'll be passing them to the instance so that we can use the same values here to access the database. Okay, so now we created this info variable. Let's see what happens next. So in order to open a connection, we should use this code over here. Okay, which basically opens like a Postgres connection to using this PSQL info string that we built over here. Okay, and this function here returns an error if something goes wrong, so we need to check on it. This is like an idiomatic way in Go to handle exceptions. It might be different in other languages, so this is how it's done in here. Basically, this function returns two variables, db and error, and we need to check that error is not is nil first before proceeding. So in this case, if it's not nil, we just, let me use this log fatal call, just print out what wrong happened. If not, then we need to make sure that we close the db after we're done. Okay, so let me just here type connected. Okay, so basically what happens is that if we try to open the connection and nothing went wrong, this message is going to be printed out. Okay, so how this open function works is that it opens the connection, like it tries to open it or prepares to open it, but it does not actually connect to the server. So even though I don't have a Postgres instance running, if I try to run this code, this is something that I need to add. Yep, here. So I'm just telling Go how to deal with Postgres servers, because this is like a generic SQL package that works with any SQL server. And let me quickly initialize the Go module here. And save again. Okay, cool. So if we try to run the code again, it will print connected right away, even though we do not have a Postgres server running. And that's what I was just saying, that this open function just prepares the DB variable here with the required parameters, but it doesn't actually connect to the database. And to do that, to do the actual connection, there is this ping function that we can call, which basically just tries to connect to the server and returns an error if the connection was not successful. So what we will do here is we will try to ping the database, okay? And if this ping request here did not go through, an error object will be returned. So if error is not nil, then something wrong happened. Cool. So let me try this out and see what happens. And it should not work. Exactly. So trying to connect did not happen because connecting to port 5432 did not work, because basically the server is not running. Okay. So let me quickly spin up a Postgres instance. I know so far this has nothing to do with how configurations work, but we're just building like the base structure of our app here, example app. So to run the Postgres server, there is a Postgres image on Docker that we can use. Let me quickly grab it from here and check out its documentation. And it's a good chance also for us to explore how to use Docker Hub and its documentation. So the image name is just Postgres, so we should do something like Docker run Postgres. But let me use a specific version here, this Alpine version, because it's like a smaller. I can just download it quicker than this latest one. And what else do we need? So yeah, two things. First thing is that I need to expose the port for Postgres to my machine, because as I mentioned last time, a Docker container is just like a virtual machine, like a different system or a machine running inside of my computer, and it's its own machine, which means that anything running inside of it is not exposed to the outside world, so I cannot access it from my laptop directly. I need to explicitly say that something is exposed or exported out of this virtual machine or container to my host machine to be able to connect to it. Okay, and to do that, I'm just telling Docker here that there's some service running inside of this container on port 5432, and I want it to be exposed on the same port on my machine. And this left bit here can be changed. So for example, I can just say export it to port 4321, but that means that in my code, I would need to change this port here to 4321. Okay, so for the sake of simplicity, let's just use the same value for Postgres. Okay, so yeah, that's one thing. Now if I ran the database, it will be running on this connection. Okay, but I need also to pass like the username and password that I will be using to set up the Postgres instance. And to do that, if we just scroll a little bit to the bottom here, we can see that this can be configured using something called environment variables, which we will talk about in a bit. And these environment variables include like a password, so I can pass in a password. And to do that in Docker, we just use the -e flag, so -e password equals secret, -e user equal root, -e, there's also some variable for the database name, equal app. Cool. So now we passed in the correct configuration to the Postgres instance. One last thing I want to add is like this --rm flag, which basically tells Docker to delete this container from my machine whenever it's done executing. Okay. So once I hit enter, there's something I did wrong here. Yeah. Okay, so this should be a column because Alpine is a tag, not part of the image name. So if I try this again, yeah, it should start printing like the startup sequence of Postgres, and then it ends with this line here, which means that the database is now ready. Okay, but as you can see now, like if I try to write anything else, Docker is not giving me back the terminal here, so I cannot write any more commands. And this is because it's basically running Postgres in the front, and since it's a server, it's like it keeps on running until I explicitly switch it off. Okay, so there's a way to run this Postgres server in the background, and to do that, let me close this instance first by hitting Control C. Okay. And using the same command from before, we can just add this -d flag, which basically is short for daemon mode or background mode. And when I hit enter, now what Docker does is that it prints out some ID that refers to the container that it just created for Postgres, and it gives me back the terminal, so I can type anything I want to do inside of here. And to check and make sure that this container is actually running, we can use another Docker command, which is docker ps. And we can see here that it says there's like a Postgres Alpine container running on port 5432, and this is the ID for this container. Okay. Okay, so since now we have Postgres running in the background, let's try to run our program again, and it should print out that it's connected. Hopefully, yes. So now our code here is connected to the Postgres server. Cool. Okay, so since we have our app complete, let's work on introducing configurations. And to do that, as I mentioned, the configuration values should be present in an external file, and in this case, let me call it config.yml. Okay, and inside of this, let me just bring in these values because we want to remove them from the application. Okay, so I'll be removing them from here. And let's add a to-do here, import values from config file. Cool. And inside of here, let me print these values. Okay. So now these values are over here. I need a way to be able to read these values from the external file and write them inside of here. And to do that, so there is a way for Golang to read YAML files. Let me quickly search for it. Yeah, so there is this package here, go YAML/YAML, that can allow us to read YAML files. And I believe they have like a quick... So I need to import this first in my application. And as far as I remember, there's an example that says how we can do it. Yeah, so this one here. Yeah. So under this to-do here, let me paste that code. And it also needs this struct that I will define in a minute, okay? So basically what this does is that it calls this unmarshal function. And this unmarshal function receives like an array of byte, which can be data read from a certain file. And then it, like after parsing the data inside of here, it puts it inside of this t variable, okay? There's another way to do it if we're working with files. I'm not sure if it's included in the example, but yeah, let me just write it from scratch, okay? So first off, let's define. Let's write like a constant here, which says config file name, and just define our config file inside of here, config file name. And then first we need to read this file or create like a file reference to it. And to do that in Go, we just use os.open and give it the file name. And this function returns an error, so we need to make sure that nothing wrong happened. Okay, and if everything is fine, I need to make sure that I close the file after I'm done. This is just some cleanup that I do. Okay, and then to parse the contents of this file, we can use from the YAML package something called a new decoder, and this accepts F, the file, and it decodes this into like a variable of a struct that I'll create right away. Okay, so an easy way that this package gives us to parse values is that if we have like a class, or in Go it's called a struct, called config for example, and this struct has the same like the same naming convention or the same name of the keys inside of the YAML file. So let me open the YAML file again. So if it has the same names as in here, so this YAML package will automatically map whatever inside of the file to the variables inside of this class. Okay, so let me quickly do this. So all of these are strings except for port. And if I create a new instance of this class here, let's call it C, and pass it over here, I can directly decode the file into this variable, and I also need to check if something is wrong before I can proceed. Okay, so let me save here. So now it's downloading the YAML. Yeah, okay, cool. So it's imported here. So everything is as expected. The last thing I need to do is to read these values from this config class instead of having them as local variables. So we can just say c.host. Let me do this quickly. Oops. Cool. If I save now, yeah, it should compile properly. So let's try to run the program again. Go run main.go, and it says connect again. Cool. So now we don't have anything explicitly hard-coded, any configuration values hard-coded inside of here, except maybe for the file name, but that's fine because it's not sensitive information. And the code is still running. And just as a sanity check, let's print out this variable, this C variable, just to make sure that the values are actually being read into it. Let me run the code again, and we can see that yes, the variable includes the values inside of the YAML file. Okay, so this first version of our code now replaced the hard-coded values with values provided by the config file. But again, as I mentioned, having a config file in my repo exposes the probability of including it in like our source control, which is a problem because we still have the actual like sensitive values inside of here. Okay, so what is the alternative? Let me jump back into the slides to discuss this. So the alternative is actually the second vocabulary we were learning about in this concept, which is environment variables. Okay, so what is an environment variable? It's basically like a value, like a variable that is defined, that is available for our app, but the difference is that this variable exists only in the runtime. And what I mean by that is that it exists somewhere that I don't have to worry about. The only thing I need to know is that it does not exist like on the disk, so it's not on in a file or something, as if it's like in the air. So it's like oxygen. I'm just breathing it inside of me. I'm using it and then doing whatever I want with it. Okay. I'll show exactly how to define these variables and how to use them in the code, but this is basically what an environment variable is. It's something that cannot be found on disk, but it exists and it's available for our apps to use them. And examples of these variables are the temp variable, which is basically a way to tell our application where to create temporary files if it needs to create any. There's also like the home variable, which is which holds the path to the currently logged in user's home directory in case we also need that. So these are two examples of environment variables, but we can even define our own variables. There are other pre-existing environment variables that we can use, and so on and so forth. And how they look like, or the convention for it usually, is that like the name is basically in uppercase like that, and then they're also assigned a value. Okay, and what's really good about this is that, like, if we go back to configuration files, we would need to have a configuration file for every environment that we have. Okay, so if we have like a local environment, a staging environment, and a production environment, that means that we need 3 versions of our config file, each containing the values for each environment. Okay, and this might be a little bit of a headache that we need to handle whenever we're deploying our apps to new environments. What's good about having environment variables instead is that they are injected directly into the environment. And what I mean by that is that like the server where the production app is running can be configured to provide these variables to the applications. And that means that the application doesn't have to worry where these values came from as long as they exist. Okay, and that's a really good thing, because now when we want to deploy to a new environment, we just have to worry about adding these like variables to the environment of the new environment we're building, and don't have to worry about like creating files or something that allow our app to run from them. Okay, and since these files do not physically exist on the disk like in our source code, there's no chance of them being checked into the code repo accidentally. Okay, so let me show you a quick demo about how we can create these environment variables. So for this, like I'm using Mac here, and it has like a Linux terminal. So the way to do this is using the export command. Okay, it might be different on Windows, but there's definitely a way to do it on Windows as well. And for the application, it doesn't really matter how it was defined, whether it was using like a Linux command or a Windows command. There's just one way for my app, for our app, to access environment variables, and I'll show it right away. Okay. So here I can just say export, for example, a variable called Rami, and the value of it is Abu Naga. Okay, and when I do that, if I try to type echo, which basically prints whatever is passed next to it, and then use the $sign to indicate that I want to reference something from the environment, like an environment variable, and say Rami, we'll see that it prints out Abu Naga. Okay, if I try printing something else, so foo, it will print out nothing because this variable has not been defined yet. Okay, so basically what I can do is just like export, and for example say db name equal app export blah 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 and so on. But to make it easy, let me, for the sake of the demo only, include all of my variables inside of a file. So this should not be done actually in production. It should be done using the command line as I showed, or some other way, depending on where you're deploying your app. But for the sake of the example here, I'll just create like a file called env, include inside of it like all of our variables here with the same naming convention. Equal, and like that. Okay, and to load all of the variables inside of this file at once, I can just use this env command to do it, and tell it just to cat config.env x-args. And what this does basically is that it loads the config file, it reads it line by line, and execute each line of these lines as an export command. So basically introducing this environment variable to the environment. Okay, and in order to make these, this should be a $sign. And in order to make these variables available for my app, I can directly afterward just type the command that runs my app. So if I say main.go, okay, so now it prints connected because it's still using the config file. The config file. But let's switch it to using the environment. But this command here ensures that the values mentioned in the config.m file are available in the environment. Okay, and again, as I mentioned, this should not be the way to do it, reading from files. But variables should, like environment variables, should be injected in like using the export command or some other way, depending on where you're deploying your app. And most of the cloud service providers have a way to configure these environment variables like with a way without having to use files. Okay. Okay. So what we need to change here is, first off, we'll get rid of these, because we're no longer reading a file. I'll also get rid of this and YAML, and then let me define back the variables that we had in the beginning. Currently, let them be just empty strings. Maybe the port will be 0. I'm just setting them like to their default values to make sure that the code is compiling first. If I hit save, cool, it gets rid of the extra import statements and the code still compiles. And if we try to run it, it does not work because nothing is configured. So now we need to fill up these values, but instead from doing it like in a hard-coded way or reading them from config files, we need to do it using the environment variables. And to do that, there's like a command called getenv, which is present inside of the OS package in Go. There's like a different way to do it depending on the programming language you're using, but in Go it is just os.getenv, and inside of here we pass it the same value for the key that we had in the file here, or like in the export statement. Like for example, if I have like export ROMI equal naga, then I would use this ROMI bit, okay, and I'll just put it here. Cool. So let's use the same variables we have here. Let me do this. Okay, and just type os.getenv host. Okay, and as a sanity check, let me print them out first before using them in the code. So yeah, can I just paste this? Log.print host equal. Let me do it like that. So this should print out like each of these variables. Cool. Okay, so let me try to run this again first without like loading the environment, and we can see that the values are empty except for this user one, maybe because it's like there's already a predefined user variable in Mac or Linux that says what is the name of the user currently logged in, which is currently Ramino. So let me just like prefix these with db maybe, so that they do not conflict with pre-existing variables, and I need to do the same over here. Anyway, so now if I try to run this code again, it should print empty values for all of the variables, exactly like that. Okay, now if I try to do it using the command that loads the environments from the file, we can see that now, yeah, it reads the values correctly from the environment. Okay, and what I need to do next is that so what is going on over here? Yeah, so now because this getenv reads strings only, so we can see it always returns a string. To use the port, we either need to change this port here from %d to %s, because %d means we're passing in an integer. So we can do that, or we can just like parse this value using a built-in package in Go that is called atoi. And the underscore I added over here is because this atoi function returns an error, but I'm explicitly ignoring it for now, just taking in the port value. So let's try to run this again, and we can see it prints out connected. Cool. So yeah, this is basically how we were able to replace like the hard-coded variables, configuration variables for our app with configuration files first, and then replace these with environment variables, which make it even more easier for our app to be deployed to different environments, because now all we need to do is to inject these environment variables into the environment, the execution environment, and then our app will be able to pick them up and use them, similar to how they were when they were first hard-coded. Okay, so I guess this wraps up this part, this config part, and prepares us to move to this next factor here. Let me first pause for a couple of seconds in case any of you guys have any questions. Not sure how many is watching right now. So if all is good, just let me know in the chat so that I can proceed. Okay. So far, so good. So the next factor I'll be talking about is factor number 5, which is build, release, and run. And this makes use of having configuration environment variables to make our like CI and CD pipelines run even faster. Okay, and what this factor is responsible for is basically dividing the process of deploying our apps into 3 stages: a build stage, which transforms our code, like the human readable code, into binaries and executables; a release stage, which combines this binary, which is the output of the build stage, with some configurations, those being like from a config file or from environment variables, and put them together. And then the last stage is basically executing this combination. So it's executing the code or the binary that we created in the first stage with the configuration that we attached to it from the second stage. Okay, and why having these 3 stages is important is because usually like this build stage takes a long time. Like if you're coming from Java, for example, we know that it takes a long time to build our jars or compile our code. Also, if you're coming from C, or like a lot of languages, even Go sometimes needs a long time to be able to build and create like the final product that is able to run on its own. So that's why usually this stage is separated from the rest of the pipeline, or like the rest of the process. So we build it, we have the binary ready, because usually like running the binary doesn't take that much time compared to building it. The second step is combining it with like a config, and then this combination together is called the release, which is basically like a certain version of our app that is ready to be run. So we can talk about our app as a set of releases. Whenever we need to introduce a new change, we create a new release, and this is basically what is mentioned by this factor here. So usually what happens is that deployment tools offer a way to manage the releases in a manner that I mentioned right now, which is creating new releases for new versions. And this introduces the ability to be able to roll back to previous releases whenever it's needed. So for example, if you pushed like a new feature in your code, and this feature went through your CI and CD pipelines, and there was a bug in this feature that was not detected by your test suite, so it made its way all the way till like production, but then you found out about this bug and you still need time to fix it. You don't want your production app to be down because of it. You can use the concept of having releases to be able to roll back to a previous version of your app. Okay, and it's easy to do this because, as I mentioned, releases are combinations of a built binary and the config file. So if I have my releases defined, I can switch between them easily. Okay, so I can just roll back to a previous release until I fix the current one, and then I push a new release to introduce this fix to the production environment. Okay, and because the built binary from the first stage runs in almost no time compared to, as I mentioned, how much time it needs to be built, we can do this rollback really quickly without having a very long downtime. And there's a way where this is done by the different release management tools, where it just creates like a new folder for every release of your app and creates a shortcut or a symlink that points to the latest version or release that should be run of your app. Okay, this should not be the only way to handle it, but this is like one way of handling it, or how different release management tools handle it, to make it easy to switch between the releases. And because now it just changes where the shortcut or the symlink points to be able to change which version of the app should be run. And like there's a naming convention for how these releases should be named. It should be a unique name to allow for different releases to be there. It could be formed of like a unique ID or maybe like a version number. It really depends on your team and how it's comfortable with naming the releases. But a very important note that we need to keep in our minds when it comes to this factor is that you should never change a release once it's created, which means that the releases are immutable. What I mean by that is that if, for example, you need to introduce a new feature, you do not change an old release, but instead you create a new release with a new version or a new unique ID that introduces this feature. Same thing is also with bug fixes. So remember when I was just talking about rollback and I said that if there's a bug we can roll back, when this bug is fixed, you do not modify the release that was buggy. You actually create a new release that is newer than the buggy release and then run or deploy this release, which means that the releases are an append-only ledger. You can just only add to it, okay? And any changes should be created in their own release. Okay, so yeah, this basically sums up what I had to say today. These are the two factors I wanted to discuss. Yeah, as always, if you have any questions, feel free to shoot them at me in the chat, or maybe later on, if you're not watching this video right now, feel free to contact me anywhere to discuss them. And yeah, so we are halfway through the course. It would be really great if you guys can share with me your feedback, at least those of you who actually watch the video, either like while I'm live or later on, because your feedback is really important to make the next sessions even better than now. And as always, the slides is available in the link that I shared before. I also type it down in the chat right now for those of you who don't have it. I always update them before the session so you can quickly go through them to get an idea about what I'll be talking about. And the GitHub repo is always updated also with whatever code we have written or I have prepared before the session to demonstrate the factors I'm discussing. So yeah, this is what I have to say. Thank you very much for watching and see you next time. And stay safe. Stay safe.